Typically, anybody that's driven a car has had the experience of getting in, turning the ignition, and either hearing clicks or nothing at all. And it really reinforces the importance of electricity in so many of the devices that we use. In fact, without electricity, most of the devices are simply nothing more than annoying. So if there's no power, there's no show. It's really true in the case of computers. You can have the best processor, the most advanced memory, great hard drives, lots of server applications, but if there's no power to the motherboard and the other components, nothing will happen. It's literally the difference between life and death for the system. You can kind of think of a power supply as the heart. The heart keeps the body alive and allows the brain to function, just as the power supply keeps the system alive and allows it to do all of what it does. So let's just take a few minutes to look under the hood, so to speak, with power supplies in personal computers.
In order to have a better appreciation for what power supplies do, you need to have at least a basic understanding of how electricity and electrical components operate. So let's just take a few moments to review some basic principles that will help guide us in our discussion of power supplies and electrical forces. One term you're going to hear a lot is the term volt. And one of the things that you can do is equate voltage to force. For instance, with water pressure. You could think of water pressure as analogous to voltage. So in this case, we're talking about the force of the electricity. Now there are more technical understandings of the term voltage, but this is just a great layman's way to be able to understand how it works. This is an example of a low amount of force. Just a fountain that's just basically allowing the water to leave. Nothing extraordinary about the pressure in that amount of water. You can see that in this diagram. However, in this case, you can see the water coming out with a great deal of force. If you have low voltage, it would be analogous to what we talked to about the low water pressure. And here, high voltage with a higher amount of electrical pressure. Again, it's just sort of a layman's term to be able to understand how this operates. Another term you'll hear frequently with reference to electricity is that of current or amperage. And this has to do with the amount of electrical energy flowing through the circuit. We talked about voltage being analogous to force. This is just the volume or amount that's running through a particular electrical circuit. So in this case, we look at this flowing river. It's fairly narrow. There isn't a huge amount of water. So this would be analogous to a low amount of current. In essence, a lower amount of water. Not necessarily the force by which it's flowing, but just the amount of water itself. It's a very small stream. But when we look at a river this size or some kind of an inlet, this would be analogous to a high amount of current. You could see there's a vastly larger amount of water in this particular picture as opposed to the small stream we look at in the other. So you have voltage being analogous to force and current being analogous to the amount of electrical current, which is measured in amps or amperage. Another concept is that of resistance, and this is measured in ohms. Ohms measures resistance in an electrical circuit. You could think of resistance as sort of opposition to the electricity flowing, something that's essentially slowing it down. This would be an example of a low amount of resistance. You see there's nothing really in the way except for a few branches of this particular water flowing where it is. It's going with very little resistance, very little opposition. As you look at this hydroelectric dam or spillway here, this actually creates a high amount of resistance. Notice that water is flowing through, but the vast amount that's in this particular instance is being restrained or blocked. So this kind of gives you an idea of how resistance works, and this is analogous to a high amount of resistance. One last term you're going to hear frequently in terms of electricity and certainly in terms of power supply is the word watt. And watts are essentially the amount of work performed or could be performed by electrical current. It's kind of a rate of energy conversion. So if you take volts, we talked about being analogous to water pressure, and multiply that by amps, which remember is the amount of the electricity, and you end up with watts, or essentially the rate of energy conversion. Now there are more than one different types of electricity, some which you may see as very common, others which may not be as familiar. In this particular case, you're going to probably run into one of these two types of electrical current. The first is called alternating current, which was actually pioneered by George Westinghouse a number of years ago. And it's typically what you see in your homes and businesses. When you have the outlet in the walls, this is typically what you're going to see. In alternating current, the direction of the electricity changes. If you again think of a river flowing, it may be flowing one direction in one moment and then back another direction in another moment. So the direction of the electrical flow changes, hence the term alternating current. Alternating current typically also has a frequency, and this is typically going to be between 50 and 60 hertz. Hertz, of course, being the unit of measure of frequencies, in fact. And as far as actual voltages, you're going to see voltages from 110, 120 volts AC, which is sometimes abbreviated VAC or volts AC, up to 230. Now, there are some variations within these ranges, and you're going to have one type in the continental United States and Canada, and you're going to have another type internationally. But this is typically the volts that you're going to see ranging with alternating current. Direct current, which was actually pioneered by Thomas Edison, the inventor of the light bulb, uses an entirely different set of principles for operation. It's used by various devices, not typically household devices, but things like cars and boats and electronic devices such as radios. These all use direct current. The direction of electricity with direct current is constant, hence the term direct rather than alternating. So the direction just remains constant. It doesn't change. Direct current has no frequency. It has a frequency of 0 essentially, so that's something else to keep in mind with direct current. And voltages are going to vary by device. Many cars use 12-volt batteries. Motorcycles use 6-volt batteries. There are different types of batteries that are used, for example, with different electronic devices, AA's, A's, D's, C's, and so forth. So the voltage is going to vary by the device that's in use. And that is a basic overview of electricity and electrical principles in general, and will help us as we continue further in this lesson regarding computer power supplies. Now that you have a fairly good idea of the basic principles and fundamentals of electricity, it'll help us to discuss power supplies in much more detail. What we want to do in this next segment of the lesson is actually look at the architecture of computer power supplies. Again, they're an essential component and something you need to be very, very familiar with. So we start by looking at a typical power supply. What you see pictured here is very typical. You have a fan which draws air through the power supply and helps to be able to cool it off. Remember that electrical components generate heat, and power supply is no exception. You have a power switch, typically that turns on and off. You may also have another one on the front of your computer, but typically power supplies will have a rocker switch such as you see here. Now for years I didn't really understand the significance of 0 and 1 on it, and it has to do with on and off. 0 being off, 1 being on. It's simple binary math. Next you have your 3-prong power receptacle that uses that standard connector that you see on just about everything. Now just as the other connector types that we've talked about and will talk about throughout the course have official designations and technical names, this 3-pronged plug on the back of the computer is no different. It's actually called the C14 connector, and you actually see it on a lot of electronic items. The male end is actually called the C13, so it's important to know these technical names along with just the more common colloquial expressions. Now keep in mind that power supplies are rated in watts. This is one of the reasons we went over terminology. You can have 250 watts on the low end of power supplies, and that'll affect how many connectors you have on it. And you have 750 watts at the very high end. Now the higher wattage capacity power supplies give you more connectors and the ability to be able to support more components. For instance, hard drives, CD-ROMs, DVDs, expansion devices, USB, and so forth. So it's important to make sure that what you have as far as a power supply will enable you to support the various components that are already in your system. This can be particularly important if you're replacing a power supply. I actually had an experience where one of the connectors that I got on the power supply for a computer I was giving to my son and daughter-in-law was missing a connector, and I didn't think anything about it, and so the computer wouldn't boot up. So I had to go back and get one that had the particular CPU connector in this case to be able to have the computer to boot up. So true story. One thing I did forget to mention here, but is in our diagram, is the voltage switch. Again, this just has to do with the input voltage you're expecting, whether it's 110 volt or 220 volt. So next, within the system, there are different connectors that come out of the power supply and obviously into various components of the system. And we just want to take a little bit of a look at that. We start again just sort of looking globally at a power supply. You can see a number of different connectors here. But let's talk about the different types of connectors. First, you have the P1, the 20-pin connector that you remember seeing on our motherboard. This is actually pictured here. It's keyed, you'll notice, so it can only go in one way. There's also a 24-pin P1 connector, and essentially what you see out there on the left was the connector that I had mentioned that I didn't have on that particular power supply that caused me all the problems. That's your P4 connector right there. You have your Molex connector. This is actually one of the most common connectors across all computer systems. And this actually connects hard drives, CDs, DVDs, Blu-ray connectors, and so forth. This is a full-size Molex connector. There's also a mini Molex connector, which is pictured here. And this is typically for being able to connect floppy disk drives. Next you have SATA connectors. This is serial ATA. And this actually can enable you to be able to connect SATA hard drives, CDs, DVDs, Blu-rays, and so forth. And then you have the PCIe, or external PCI connector. This actually allows you to be able to connect devices external to the system, PCI Express connectors. As a PC hardware technician, one of the activities I can almost guarantee that you will be called upon to perform is that of power supply installation or replacement. And there's some aspects of this you need to keep firmly in your mind as you approach this particular type of device. Now let's start with safety. You have to realize that power supplies are electrical components, and they contain high voltage, particularly in capacitors, which can actually give you a nasty shock. So you need to understand that in advance. Also, if you'll notice, this particular power supply is open. That's a bad idea. There are no user serviceable parts within the power supply. Many years ago, there used to be a fuse that you could replace, but honestly, it's going to be a lot easier just to replace the power supply than to try to open it and get involved with these different components that can actually shock you. In fact, power supply components are not FRU, which stands for Field Replaceable Units. And the bottom line is, don't try to repair a defective power supply. Because it's an electrical device, you have to use great caution, or you could end up like this fellow, with a nasty shock and potentially an injury. So always be very careful with power supplies.
If the processor of a computer system is the brain, then the power supply is certainly the heart, because without the heart, the body can't function. This power supply is actually what we would call the heart of this particular system. You can see the inputs, your on and off switch, and a myriad of connectors. It probably looks a lot like wrestling an octopus. The installation process is pretty straightforward. You actually begin by putting the cords into the system in this way. Once all the cables are successfully inside the system, then it's simply a matter of aligning the power supply with the back of the system, sliding it in, and then securing it with screws. And that's pretty much all for the physical installation portion of affixing a power supply to a computer system. As you can see, we actually have the power supply fixed inside the system. Now we need to actually connect everything up so that it will work correctly. We'll actually start with the main connectors as you see them right here. The connector for that is right here on the motherboard. So it's a matter of making sure that everything is aligned correctly. Push it in until it clicks. Similar procedure on this side. Next, we have a few other CPU type connectors that we want to make sure are correctly there so that the CPU fans will run as expected. So we have that connected, we have these connected, and we're good to go.
So to wrap up, let's just look at a few different terms that we've looked at. Volts is the electrical force that essentially drives current. Current is the amount of electrical energy flowing through a circuit. And watts is the amount of work performed by electrical current. Remember, volts times amps equals watts. And most power supplies are actually spoken of in terms of watts, what they're capable of doing. We also talked about alternating current. The movement of electrical current will periodically change directions. Again, this was discovered and developed by George Westinghouse. And then you had direct current, which the movement of electrical current flows in one direction only, doesn't change direction, and this is the type of electricity pioneered by Thomas Edison.
Wasn't that shocking? Yes, I know, bad joke, and I'm known far and wide for my twisted humor. It'll never get any better, trust me. But what's not twisted is the purpose of the power supply and the importance it plays in the role of the personal computer. It gives life to the system. Have you ever noticed that when people have irregular heartbeats, they actually apply electrical power to get things back in rhythm? It's the same way with the personal computer. Without a steady stream of power, heartbeat so to speak, the system won't function. So make sure you always take this particular part seriously and make sure it's healthy and happy.